Good afternoon, everybody. Thank you very much for joining us. We have myself, Jerry, and Arsen from Genware Computer Systems on the line. I'm going to take just a few seconds and introduce you to Genware as a company, and then I'll hand it over to Arsen so that he can take us through anomaly detection, showcasing an example using transactions, financial transactions, and fraud. So Genware Computer Systems is what I like to refer to as the smallest global company. We've been operating, we're a New Jersey-based corporation, and we've been operating now for just on 21 years. So we started in '99. Our head office is in Wayne, New Jersey, just outside of New York City. We have office locations down in Florida, but our service area is across the US. We also have teams in Montevideo, Uruguay, Johannesburg, South Africa, and we have offices and a sister company in the United Kingdom in London. At Genware, we have evolved, as most of our customers have, in the field of leveraging information as an asset. Genware started out building systems that were revolving around data warehouses and data marts and reporting systems and ad hoc querying with business intelligence to today what is a full analytics stack and a full analytic platform. Taking a look at the diagram shown over here, we start out by focusing on sourcing and providing access to data. Very often that requires the integration of data from different systems. In today's age, we also need to use a platform that allows us to handle new types of data and the new speed with which data comes at us. All the devices that are available now makes it important that you can use your static internal system data along with data coming from streaming data sources, whether they be IoT, whether they be transactional systems, or whether they be production, procurement, or production type systems. We then have to optimize the use of that data, and we use TIBCO's data virtualization. We cleanse that data with a TIBCO master data management stack, and we then start leveraging that information through visual analytics, through data science, and through streaming analytics. On the data science, there's various modeling techniques. We use the TIBCO data science platform to build and train and deploy models. We use the visual analytics to explore data, but also to communicate that data. One item over here that we do add in is natural language generation. Natural language generation allows us to add narratives to our dashboards to easily, in a written word, explain what the information is telling us or what's being communicated. We can also leverage our data and actually produce emails or letters or reports that are completely written using natural language generation. Genware is an elite partner with TIBCO. Our partnership's been just almost about 10 years now. Our business together has grown rapidly, and the reason why we leverage TIBCO technologies is because they have the vision and foresight of growing this analytics platform. When we started with business intelligence, the next logical step was visual analytics and exploration tools, but that's rapidly grown into the data science field and the advanced analytics field. We do have a video, and in the slides and recordings you'll have access to the video just speaking about the partnership between Genware and TIBCO. We were the proud winners of the TIBCO Now, or at the TIBCO Now conference, where we won the Partner of the Year award for analytics in the Americas last year, and then previously we had one as well. The core technologies that we use are Spotfire, Streambase for streaming. We leverage ComputeDB, we leverage TIBCO data virtualization. We deliver information with the TIBCO data science platform, including Statistica. We do master data management with the EBX platform, and then we do integration as well, where we need to take information and send it back into the operational systems using the TIBCO cloud integration stack. That's going to be all from me today. I'd like to thank you once again for joining us, and I have the pleasure of introducing Arsen, who's going to take us for through our anomaly detection solution for the day. Arsen, over to you.
Welcome everyone. First one, Streambase. It's an industry-leading event processing platform. If we need to define in some way, in the simple way, it's the event processing platform in which we can apply mathematical, statistical, any kind of transformation, any kind of action over real-time data streams. From simple things like pivoting, or casting, specifically applying statistical models, but this works for real-time streams, like live transactions that are coming into our inputs. The second piece, it's Live View or Live Data Mart. Live Data Mart, it's an engine that provides a business intelligence capacity, but for live streaming data. This works together with the Streambase in order to put an action over each row, over each transaction that is coming into our system. Then the Live View completes the equation because Live View has a server which provides a web-based dashboard for analyze the data that's coming into Live Data Mart. It also has a desktop to work very similar to how Spotfire it's designed, but it's different. It has another approach. We can substitute also Live View by Spotfire, but let's talk about Spotfire later. The last piece is TIBCO Artifact Management Server, which is a server-based component to manage the life cycle of artifacts. I mean artifacts, what I try to refer with artifact, can be a model, can be a decision table. In this way, the users can manage the whole cycle of the approval process for each model, for each artifact. For example, we can have a data scientist improving our models or artifacts, and the deployment process goes across another line in the timeline. Each time in which the data scientist has a new version, it can deploy using the artifact management server, enable that to the live data mart or stream-based workflow. With all of this, we are ready to process real-time data and obviously to analyze and act. That's the best benefit in abstract terms of all of this. We can act in time, which provides multiple benefits, because it's not only to know what is happening, this is one more step in the analytics life cycle. This allows us to act in the exact moment that we need to act. Continuously query, if we need to map concepts in here, to analyze data, we need Spotfire or Live View Web or Live View Desktop. To continuously query, we need Live Data Mart and Streambase. And to act, we need Streambase and again, Spotfire. This is a good tip, this is designed for real-time applications, but it's completely compatible with batch processing and big data integration. Let's move to this TIBCO Spotfire. We are not afraid to say that it's the most complete analytic solution in the market because it allows you to analyze historic and also real-time data. Any type of data, we can work with structured data, we can work with unstructured data, we can transform data. It's a very powerful tool. It's a very easy and fast time to market tool that provides the capacity to build and work and analyze dashboards, and also supports multiple forms of data and a very heterogeneous data sources. The last piece is data virtualization, because once we go with all of this into a real life use case, we will have multiple different heterogeneous data sources, and we need to govern that. So we need this amazing tool to stay away from the typical ETL processing and replicating data and losing time. With TIBCO data virtualization, we can just plug, transform, and virtualize each data source and provide homogeneous interfaces to the final applications that the consumers, that can be Streambase, can be Spotfire. And also it's a very good point to have your data governed, secure, and accessible for many different users. Also, you can split the job between the technical experts and the business users. Once you have TIBCO data virtualizations in your company, you will be able to delegate the complex parts of data cleansing, data transformation, data consumption to the technical experts, and just leverage the analytics and the business development or thinking to the business users. Now that we have some background, we will talk about the management accelerator, the risk management accelerator, which is our scenario. We are talking about a TIBCO connected intelligence platform solution. It's not a solution that is based in nothing. It's a solution that is based in a very exciting platforms. The main objective is to reduce the expenditure on fraud detection, which is the digital business problem that we are trying to solve, the expenditure on fraud detection. And this is going into 3 different lines, mainly reduction of false positives. Some studies on the industry says that the 50% of the positives, potential fraud positives are false positives. That is a lot of money. Also increasing the productivity of the people, because if you can leverage some stuffs to machine learning processes, you can release some human resources activities, operative and manual activities, and also minimizing the time spent in investigations. All of this is supported by the machine learning processes, but applied into a live streaming data. It's not the typical solution of machine learning that it's applied over data at rest or over historical data. This will be applied in time over your data stream. Some trends that supports the fact that we are resolving an industry key issue, an industry key problem. The 80% of the fraud detection systems are applied into the next year to resolve frauds, more or less. More than today, it's a very low, it's more or less under 10%, but in the current year and next to the next year, we will be reaching to the 80 and 90%. About the business scenario, we are close to present the accelerator features, but first about the scenario. The first and easy way to define this, it's like a sophisticated fraud detection system. But why we need this? We need this mainly because, legislation and market dynamics in the time that we are having more computation capacity, more quantum computers, the fraud strategies are more and more complex. Then we need complex systems to analyze that and to prevent that. Also, the prevention avoids the losing of money, and time itself is money. What is our method and our approach? A very effective surveillance system. This is another kind of definition of our risk management accelerator. It's a very effective and in-time surveillance system. It's scalable because it's ready to connect to any kind of data or data source, or to scale to process multiple inputs, frameworks, and input streams. And it's intelligent because it has a very powerful machine learning processing behind the scenes. Some of the features, it's very easy to adapt and change to each country regulation. We can detect sophisticated fraud patterns because this evolution. I will tell you later, but let's keep this. I will define this better in the next slide. We can reduce the false positives in the alerting stage, right? Because we have a machine learning qualifying each transaction and guiding to the final user how close a transaction can be to be a fraud or not. This is very important part. We can have the best system to detect and the best machine learning process, but if we are not alerting correctly in time, and we are not assigning tasks to specific human persons to process, also in time, we are losing the opportunity to act in the moment that we can act. So in here, it's in which the Spotfire is coming to the scene and adding the value to the whole process. Well, the scope of this accelerator is not only for fraud detection. We can apply this mainly for many different industries. The two key features that the industry must have to be aligned with this solution, it's a high frequency of transactions. You need you should have an input of transactions that could not only be a credit or financial transactions, can be just the producing of some manufactured element or anything that can be second by thousands or by hundred, one behind the next one. And the second item that it's needed, it's the classification stage. You want to classify each of that transaction or each of that events. Right? Events, maybe it's the word that it's abstract more the transaction part. So the two keys are you need a high frequency of events and you want to classify those events one by one and you want to act in time over that classification. The common objective is to maximize the number of fraudulent transactions, or in abstract terms, maximize the number of classified events and minimize the number of false positives. Let's talk about the technical scenario. We have a combination of event processing. Event processing, I am referring in this case to Streambase and to live data mart, and analytics, in which we refer to Spotfire or live web. About analytics, we have first to define the model using Spotfire. It could be using also Statistica or Spotfire Team Studio, or a plain R definition. It could be that the company has the model defined already, and we just can get the R definition of the model and deploy. So the first thing is to define a model. In this case, for instance, we have two different models, a supervised model and unsupervised model. The supervised is acting over the known past. They take the historic data at rest, and applies a data science process to define a prediction model. Based on our history, we can predict with a complex equation what the new transaction probability of fraud will be. The second one, it's an unsupervised model. It just is measuring the oddity of each transaction, mainly based on, many of fields that we have for each transaction. The country, the origin of the country, the name of the person, many facts that we know about each transaction that it's coming. We can measure how much far it's from the common path of transactions. Well, speaking about the timeline of the job after we have this deployed, we have three different roles in the company to work over this. We have different approach to complete the whole cycle of the process. First, we have a data scientist or a business users working in a Spotfire or in the Statistica or in any kind of tool that it's building the model, to work in the model, to improve the model, to validate how the model is working on against results. The second one is the engineer that installs everything, that deploys everything, that connects data sources into the real data sources, that modifies the application based on user request, and also which wants to monitor how the application is working from the technical standpoint, avoiding bottlenecks and all of that. The third role is the business user, the user that finally should act over each transaction, marking them as fraud or not. The user needs to receive alerts in time for each transaction that needs to be analyzed manually, and the user needs all the information to require it to take the decision. Here, in which we can also put in scene many different tools like Active Matrix BPM or Spotfire. We choose Spotfire to show how Spotfire can also be used as case management tool, or can be by email or Jira or any private system because we have stream-based, so we can connect that to any private system to analyze case by case or to assign job to the team. This is the final slide from the technical standpoint. This is mainly the architecture. We have a Spotfire in here, and third engine with the data scientist user creating the models and deploying the new models into the artifact management server, also connected to the historical repository. Then we have the other users in the real-time dashboards in the other side, right? We have the stream-based connected here, receiving transactions, using the artifact management services, sending alerts and cases to the case management tool or to Spotfire, consuming also elements from the historical repository, and finally sending the live data, the live transactions to the live data mart, which is in here, processing the lifetime data, and providing access in dynamic tables to Spotfire to the dashboards that will be managed by the final user and also by the managers that wants to monitor everything. I will show you now how this works. This is a stream-based server. I will not go into the details about how each transaction is working on, but trust me that we have two servers for stream-based here, which are mainly, let me go back to the architecture, one slide back. This transaction manager, these two elements that are running up as a node. We have the live view server, which is basically the live data mart server. And finally, we have a feed simulation that simulates the input of transactions. This arrow from here, it's simulating the input of transactions. I will resume in here and we will see how new transactions are generated. The value of this, it's from the Spotfire standpoint. We have four different dashboards. Let's start from the data scientist dashboard, in which the data scientist it's building the model. Let me go over this. The first part, this is a template of potential data modeling, the model creation. We have a first stage in which we analyze all our data using Spotfire capabilities. We are trying in here to define how each variable of our historic data it's useful to predict something, or it behaves different than the average. For example, we know in here that we are measuring the amount of data here. If we move to the next one, we can search for good features, which means which variables can have a very different behavior than the average of the variables. For example, this variable has many transactions that are very far from the common average, right? And the data scientists can navigate using Spotfire capabilities to find which of them are better to predict the fraudulent, the potential of fraud. In here, as we are working with historical data, we know that we have a target variable, which is if finally this is the transaction has a fraud or was fraud or was not a fraud, was a normal transaction. So if we color by the average of the target variable, we can know if, for example, any of these categorical variable has more. For example, here it's telling us that the store credit card is much more frequently used to make frauds than PayPal, than this one, or credit cards, because has the red color, which is the average of fraud it's 98%, so it's so high. So this should be it means that the payment variable should be involved in the prediction. The part two is to build the supervised model, and this first equation it's using the random forest package in R. This is developed in R. It can be used. It can be thrown also using data relationship of a Spotfire. That's to add more than just a single element to build the models. We can build the same model with this one. I tried it and it throws a very high accuracy, like 92%. So it's very good, just to be something that you can build in some minutes, in some days. Well, this tells us that these first variables are much more involved in the prediction of target variable. Then these are very statistic-oriented graphs that tells us how much good is our model. This is very easy to understand to everyone. Basically, this is telling the confusion matrix tells us, based on the history, our model is predicting all of these rows correctly. They are not finally a fraud, and we predict as a fraud. Also, these rows are predicted correctly. They were fraud, and we predict as a fraud with our model. And these are the error of our model. There are 41 incorrectly predicted. This is the actual, and this is the prediction. So there are 41 fraud cases that we are missing, and there are almost 300 of false positives. And this allows you to compare the current model that you are working on and the deployed model, because the data scientists should continue working on this after the deployment in real time, improving the model. So we will have across the time a deployed model, this is the contender model, and the current model which is trying to improve. So he can compare, once we have a better model, he can just redeploy instead the previous one. The part 3, how to learn, how to predict something if we don't know anything about the past, if we don't have a long list of fraudulent cases, we can predict based on the oddity. This is how different the data it's coming based on different variables. And this is done also based on R. It's using the PCA, Principal Component Analysis. Let's move to the last part. Once we have the two models validated and ready to deploy, we can just check the results, but the output of this job will be to have two different variables. The first one is based on the supervised model, the probability of fraud, which is based on the whole history. And the second column of the prediction will be the oddity from the unsupervised model. Then what we need is to deploy. So we have a very easy way. Let me show you in my local folder. We have a models, right? Let me remove all of this. I will say deploy the supervised model. I will say deploy the unsupervised model. Now we should have, yeah, it's there. Sorry, I was too quick. We have a new model ready to deploy into the artifact management server. So we can now move into the artifact management server. Here, it's a web-based tool, very simple. We can expand and come to here, right-click, replace with, and just upload the new file. Then there is an internal workflow that needs to be committed and needs to be approved. Because it's a very important piece, so it's not just copy and paste. See that this needs to be exported like a NOR file. Anything that you have exportable to this type of file. Okay, let's move to the last part of the demo. I will increase the feed simulation to see more transactions, like not more than 2 per second, but let's increase that. Now we will see, you remember that I told you that we have different rows in here. we check this role, the data scientist perspective, but we will move now to the business user's perspective. How a business final user should work with this to act in time. This is the dashboard that we have created. This is the home. This attempts, it's still in creation, in creation stage, but attempts to be an emulation of what a case tool or a Jira, for example, BPM tool can do for assign tasks to a user and allows a user to take action. For example, this should be the dashboard for each of the risk analysts of the company. If you have 20, you will have 20 of these. Each of one will have their own queue of job of assigned transactions. The assigned transactions are all above the threshold that we define. For example, see that in here, I have only very high rates of fraud prediction probability. So the user can come to each of these one here, click and see how this one it's in the general perspective compared with to all of the other transactions. We have a couple of KPIs in here that should match with the KPIs that the other dashboard has defined, the data scientist has defined that are more important to see, like the first piece, like the first 8, or for example, the main measures in the KPI. We have also a comparison that we can change and compare across any different variable. And also we are coloring which of the transactions have been marked as fraud by this same user, which is marked as non-fraud, and which are still on target, to be able to compare as a big perspective. If the user wants to mark, but because it's a dynamic queue, this should be going up and down based on how the user is able to work. So the user now it's able to allow transaction, or it's able to mark as fraud. Then the transaction should disappear from here. But as this is a streaming input, is not, for example, the Spotfire filter out and delete is not able to do so. The solution to make this working like as a queue needs some scripting behind the scenes to have a database dynamically modified by Streambase and Spotfire. But have in mind that once I click on allow transaction or mark as fraud, this will disappear from here. And maybe the user doesn't have enough information for this one and can go to in-depth analysis for a selected elements. Then he can compare the average measures across the whole data set, the minimum, the average, the median, and the maximum, and the particular transaction values for the long list. See, it's more than 70 columns, so it's a lot of information. How it works like a line chart compared with all the shapes. And also the same thing here, trying to change, apply across the whole different measures, how it's working like by payment, for example, in which location we should see a blue dot in here marking this particular transaction. Maybe we need to work on this a little more, but once we get this reading, will be much, I think it will be as much as powerful than a BPM or just any other case tool, because allows you to quickly analyze in deep each transaction. This is the history of how much transactions the user has marked as fraud and how they correlate all together. This is more like the risk manager perspective. The risk manager wants not to see one transaction by one as the end user that needs to act requires, but the manager maybe wants to know the whole accumulated results, like how much are like past frauds, how much are marked as fraud, and the whole workflow coming in as a big, more general perspective, one by one, how they are coming, which users have assigned, which users are more quick to resolve tasks. This is an improvement that we need to make to this dashboard also. Also completing the BPM behavior that we want to simulate with the Spotfire. We can in here also add how the user, how the team, how the risk team is working to resolve each particular incident, and also evaluating the team. We can include aspects of team performance in here, about how much accurate each person and how we can improve our team decisions. So we have a third perspective in here for the business user, but more for management in the company. And the last one, it's the technical dashboard. We can just try to monitor what is happening in the stream-based server, because this is a very key piece. Probably we will have many bottlenecks because the amount of transactions per second. So it's very important also to have. We sell in January the manager services, which is managed services. It's a service that we sell to prevent, proactively monitor the servers and how each application is running to prevent proactively any kind of issue. This is keeping that approach. This is a dashboard that tries to oversee everything from the technical standpoint, proactively in a stream-based, in live data mart, in a Spotfire, trying to prevent any kind of issue across the workflow. I am done with the demo.
Okay, Arsen, this is Sherlock. What I want to just point out to the audience as well is that this was a great example of how we're using the various technologies. It showcases how Spotfire leverages streaming data directly into the Spotfire dashboards and how we can use it, as well as how we can actually, from within Spotfire, take action on these different events that happen. While we use the fraudulent transactional risk management type solution over here, keep in mind that anomaly detection applies to any process in which a volume of transactions are coming through, where you're trying to quickly identify when there's an anomaly on the transaction itself. So leveraging the same technology, leveraging the same principles and the data science behind that, the anomaly detection piece of this could be for financial institutions looking for fraudulent transactions, as easy as it could be for a manufacturing organization looking at a process control system and monitoring for anomalies in the transactions over there. So Arsen, thank you very much for the presentation today. On your screen there is a list of contacts. Any of the solutions architects at Genway can be engaged to have a conversation about how this may be applicable to your industry. Please feel free to reach out to us, and as Jerry had indicated at the beginning, a recording of this will be posted on our blog and our YouTube channel. So we look forward to engaging and addressing any questions on a one-to-one basis. Thank you very much everybody for your time today.